Let's do some more math with complex numbers. One thing you're going to be asked to do is simplify I to some power. So here are the four main answers that could come up. We have I to the first, and we know that's just I because anything to the first power is itself. Let's look at I squared. Well, we know that I is the square root of -1. If we square that, we get the square and the root to cancel, and we get -1. That's why I squared is -1. I to the third power is -I. We could come up with that too. I to the third power would be like I squared times I to the first. Well, I squared is -1, and I to the first is just I, so that would give us -I. So I to the third is -I. I to the fourth is 1. A way to show that? Well, I to the fourth would be I squared times I squared. That'd be 4 of them. I squared is -1, and -1 times -1 is +1. So I to the fourth is +1. We could do this all day, but what's going to happen is if you do I to the fifth, you're going to be back to this answer. And I to the sixth is going to give you this answer. And I to the seventh, and then I to the eighth, and the ninth, and the 10th, and so on. So these are only 4 possible answers when you're looking for I to some power. And so we've just kind of got to figure out where we are in that repeating of that pattern. So let's give this a try. We're asked to simplify I to the 31st power. The easiest way to do this is to use our knowledge of I to the fourth. I to the fourth power is 1. So anytime we can get to ones, that's a good deal because multiplying by 1 is pretty easy and there's not much to it. So we're going to break this I to the 31st up into a whole bunch of I to the fourths. So let's see, how many of these do we need to get to 31? I'm going to need quite a few of them. I think I need 2 more maybe. So let's see what we've got here. I've got 1, 2, 3, 4, 5, 6, 7. That would get me I to the 28th because 4 times 7 is 28. So I'm going to need 3 more kind of out here to get me to that 31st power. Well, I to the fourth is always 1. So this is just like 1 times 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 I to the third, which if you think back to what we were just talking about, I to the third is -I. Well, -I times a whole bunch of 1s is still -I. And so there's your answer. Now that's a lot of writing out I to the fourth. There's a shorter way to do this. It's the same math, but it's a shorter way of writing it. How many I to the fourths did we have? Well, we had 7 of them because 4 times 7 is 28, and that gets us close to 31. So another way of writing that would be that we have I to the fourth 7 times. There's my 28 I's, and 3 more left. And I to the fourth is 1, so this is like 1 7 times being multiplied. And this is -I. Same thing here. 1 times -I is just -I. Same answer, just a different way of writing it out. If you're having a hard time coming up with this without having to write it all out, what we're really doing here is taking 31 and dividing it by 4. So take 31 on your calculator and divide by 4. You should get this 7 and then a bunch of other little decimals. What that will do is tell you this number right here. So then you can do 4 times whatever number is here to see how close that got you to this and then find out what you need left. Example number 2 is slightly different. We're being asked to simplify again, but here we've got 2 things being multiplied by 2 other things. So we've got a complex number in the first bit. We've got some real stuff, some imaginary stuff. We've got complex number in the second set of parentheses, some real stuff, some imaginary stuff, and we're going to multiply them. This works a lot like when we would do this with x's. So we could use distributive property or FOIL to do this. So if we were going to multiply, we would do 6 times 5 and get 30. And then I'm going to do this 6 times negative I root 2. Now be careful, this 6 is a regular 6. He's got to stay out of the root. The negative I has to stay out of the root, and the 2 has to stay underneath the root. So if I multiply those, I'm going to have negative 6I root 2. On the inside here, I would take I root 2 times a regular 5. So 5's got to stay a regular 5. So 5, but it's imaginary now, times root 2. And last, I've got a positive times a negative, so it's going to be negative. And we are multiplying I root 2 times I root 2. Well, outside of the root, we have I times I, which would be I squared. And under the root, I have 2 times 2, which is 4. Now, we can do some pretty cool stuff with this. Let's talk about that guy for a second. I to the second power, if you think back to what we were doing at the beginning of the video, I to the second power is negative 1. So wherever you see an I to the second power, you can always swap him out for the number negative 1. Now be careful, we have a minus sign sitting out here now. So if I have negative and negative, it's going to make this positive. So it's going to turn this into a plus. And 1 times the square root of 4. Well, the square root of 4 we can do, it's 2. 1 times 2 is just 2. So we have taken this term right here and simplified and combined it all into just a little old plus 2. At this point, I'm looking for things I can put together, and I notice that these guys are both my imaginary things. We're going to try and put those together, and they're both root 2, so that's looking promising. I'm also noticing that I have real stuff. I have this 30 that's real, and now this guy is real. So let's get this written in standard form. The real part, 30 and plus 2, would be 32. The imaginary part, I've got negative 6I root 2 plus 5I root 2. So those are both imaginary. I want to see if I can put these together. Since they're both imaginary and they're both root 2's, we should be able to do it. If you have negative 6 of them and positive 5 of them, that means together you have negative 1 of the I root 2's. So negative I root 2. And this is totally acceptable in standard form the way it's written. However, you may also see it from time to time written like this. It would be 32 minus root 2 and then is imaginary. Personally, I think this one's easier to read, but they're both correct. This one, I think maybe it's just me and my handwriting, but I feel like this I starts to get underneath the root, and that's not what we mean. We mean root 2 times a regular little I guy. And so for me personally, I like this. Some computer programs and books write it like this. Others do it like this. They're kind of interchangeable. Since this is one term, this is acceptable in standard form. Now, we've had problems where this isn't one term. It's kind of like a hot mess of things that we wish we could put together and we can't, in which case we have to use the parentheses and on and on and on. It gets kind of messy. But since there's only one I in my answer, this is actually considered in standard form. But I wanted you to see the other one because it's possible that you could see something written like this. It means the same thing. Let's do one more. Now, you'll notice this is screaming issues, at least for me. We've seen this before. You cannot have a root in the bottom of a fraction. That's a big no. But here's the new thing that you got to think about. We also cannot have an I in the bottom of a fraction because remember what I stands for? He's the square root of negative 1. So by putting an I in the bottom, you've put the square root of -1 in the bottom. That's a square root. We can't do that. So we're going to fix this similarly to how we fixed any problems that had roots on the bottom. We're going to multiply by our fancy ones. And we are going to use the same idea of difference of squares to fix this. Since I have root 3 plus I, its corresponding factor for difference of squares would be root 3 minus I. And so that's what we're going to be multiplying with. Now we've created two foils. We got to foil the top and we got to foil the bottom. Okay, let's do the top first. Up top, 1 times root 3, so that's just the square root of 3. 1 times -I, so -I. 4i times root 3. Well, 4 i's stand out and 3 stand underneath the root. And then the last, we've got 4i and times a -I. So it's going to be negative 4 and I times I, or I squared. We're going to be able to do something with that. Anytime you see an I squared, we're going to be able to do a little finagle in there. Okay, on the bottom, let's do that one. Square root of 3 times the square root of 3 is the square root of 9. The square root of 3 times -I is -I root 3. On the inside, we're going to get plus I root 3. That's good news. And last, I times -I is -I squared. Now, if we've done this correctly, exciting things should happen on the bottom. Do you see something you can cancel? How about -I root 3 and positive I root 3? Those are gone. There's other stuff we can do down here. The square root of 9 is a regular 3. And anywhere you see an I squared, we can swap him out for a -1. Now, watch this minus sign. He was sitting there already. So we had this minus sign right here. He's got to come down, and the I squared becomes the -1. So really on the bottom, I have 3 plus 1, or just 4. Okay, so let's see here. I got a 4 on the bottom. What do we have up top? Unfortunately, the top is not so nice. We could do a little bit, though. I see an I squared. Wherever you see an I squared, we can swap him out for a -1. I don't think I can do anything, though, because, I mean, this is real. This is now going to be real, but this is a root 3 and this isn't a root 3, so we can't put it together. Here's some imaginary stuff, but they're not like roots, so we can't put those together. Well, okay, let's rewrite what we have here then. So I've got square root of 3 minus I plus 4i root 3, and now this back term is now a plus 4, because it was -4 times -1. And unfortunately, there's just not much else I can do. However, we have to write it in standard form. So let's pull what's real. Well, I've got a square root of 3 that's real, plus 4. Now remember, everybody's being divided by 4. There's the real bits. Let's find the imaginary stuff. Again, everybody divided by 4. -I means the number out front is -1. So -1 plus 4 root 3, and all of that is imaginary. You can put parentheses around this one if you want to, but you don't have to. That large fraction bar right here counts as a grouping symbol that takes care of that, but you can put it there if it makes you feel better. And lastly, we're going to look to see if we can reduce. It is tempting to want to cancel these 4's, but remember, with an add in here, we could only cancel or reduce with common factors like a GCF. And since this guy doesn't have a 4 to give us, we can't pull a GCF out and reduce. Same thing over here. Tempting, but you can't do that. So I think that is all we can do for this guy. We have gotten rid of the problems on the bottom. There's no more roots on the bottom. There's no imaginary on the bottom, which would be a root. And we have put it in standard form, simplified everything we can. So we're done.